Well, I like to do a couple different versions of this experiment too. And the first one is, what would happen if I didn't start the cart right at 0? And let me just show you a little clip of what I mean by that. Well, 3 variations that this experiment can show, I like to include when we do this linear relationship. But the first one is, what would happen if I didn't start the cart here right at 0? What happened if I start the cart at 30 and just start it moving and then graph its position versus time? Let's see what we get there. Well, again, remember, when I started it at 0, this is what the graph looked like. It was a linear relationship just going straight. We can plot where it was at each point. But if I plotted it 30 centimeters from the starting point, the point I like to make sure everyone understands is I get a parallel line. It moves at the same rate, but it's just shifted up because it didn't start at the 0 point. It started at the 30 centimeter point. And the only difference between these two lines is their starting point. They're parallel, so they have the same slope, which again, in this experiment, slope is very important. Slope change in y over change in x is equal to the velocity, so the velocities were the same, but this one was just shifted up 30 units. So that's one important concept. Second one is, what happens if it doesn't start at 0 or 30, but it starts, let's say, at 80 and goes backwards? Let me just show you a little. Another change can be, what happens if I graph it going back the opposite way? So instead of starting down here at 0, we're starting down here at 30, we're starting when it's at 80, and now moving it in the opposite direction. What would the graph look like? So that's a second option I can do. What that would mean is I would have a graph, and let's say here is 80, and here is time this way. And the important thing about that graph is as I graph it, it goes from 80 down to 0 as time progresses, and I get a slope that's not positive, but a slope that's negative. And that's an important concept again. The slope is a very real thing. It is the velocity of the graph, and this velocity shows me that it's a negative slope, which means it's headed back toward the origin. And just the idea that slope can be positive or slope can be negative, and that tells you the velocity is positive, going from 0 to a higher number, or the slope can be negative, going from a higher number down to 0. Now I have one last just refinement to this experiment, and let me just show you a little clip of that one. The last version I like to point out is, what happens if it doesn't move at a constant velocity? What happens if I start it and it goes fast and then slows down? And that is my third option that I just like to talk about with you. Now, what we see there is that was a graph that started at 0, but it went fast and slowed down and stopped when it got to about 80. And it wasn't a straight line, but it was a curved line when we graph it. And we don't cover this so much in algebra, but I like to make sure and point out that now we have a curved line. We've sort of left the linear relationship, gone to calculus, which is I think a nice prelude and a nice reason for them to think about maybe someday I will take calculus. If I can study curved lines, which algebra treats straight lines. It treats some curved lines, but the beauty of calculus is it treats all curved lines. Well, again, I hope this helps show you some just variation of that basic experiment and how it can treat the line and what it tells us. Hope you have a great day. Bye-bye.